Hello friends, welcome to our channel Knowledge Amplifier. So today in this particular video, we are going to explore one very interesting use case of Cloudwatch Custom Metrics. Okay, so already in our previous video, we have covered the fundamental concept of Cloudwatch Custom Metrics. What are the important components of it? For example, namespace, metrics, dimension, etc. etc. And we have seen one of its real world use case, that is to monitor your cloud data pipeline. We can take help of Cloudwatch Custom Metrics. So just a quick recap, that is your pipeline may be running using AWS Lambda or AWS Batch or AWS Glue, etc. etc. To monitor those data pipelines, what you can do, you can keep the whole business logic within a try block, and if at all there is any exception occurs in the except block, you can handle it by simply sending a data point to a Cloudwatch Custom Metrics. Okay, and on top of that, you can obviously create a Cloudwatch alarm. That is, as soon as any data point appear in the Cloudwatch Custom Metrics, then the alarm should be in on state, and from there you can send that event to AWS SNS, and using SNS you can notify your developer team so that they can inspect the data pipeline and try to find out that why it failed actually, right? Now in this particular video, we are going to explore another very interesting use case or application area of Cloudwatch Custom Metrics, and that is in case of our API load testing. Okay, so often we build APIs maybe for our data pipeline to provide data to some users via API, or to display some data in some website. We might need to create some APIs, and before moving that particular API to the production environment, we need to make sure that the API can handle our incoming traffic, right? It should not happen that post-production deployment, when our customer is making request to that API, it is taking huge time to provide the response, because it is pretty much obvious that if the API response time is huge, then obviously customer will not be satisfied, right? So maybe to have our API response time good, we might have configured all the auto scaling and all other required features in the backend properly. But at least before going to production system, we need to test that whether our API response is sufficiently good enough in case of high traffic also or not. So that time, this Cloudwatch Custom Metrics may help us. So what you can do, you can write a simple Python code where using request module, you can basically keep on sending request to that API endpoint in a high speed, which will basically kind of mimic the huge customer traffic in our real world website, and the response time you can capture and you can ingest that data to a Cloudwatch metrics. Okay, or maybe if the API is not returning the status code 200, that means if it is throwing error or it is raising some exception, then that particular data also you can store in another Cloudwatch metrics to show that these many times API has thrown error, right? So those kind of statistics you can basically capture using Cloudwatch metrics, which obviously will be helpful for visualization, and also it will help the developer team to take certain measures to improve the API performance, right? So how Cloudwatch Custom Metrics may help us in API load testing, that part we are going to explore today in this video. Okay, so one particular API I am picking up from public internet, and that is from this particular website accreference.com. Whatever API this particular website is using, on that API we will be performing load testing. Okay, so here if you click on this particular website and go to inspect section, and if you go to the network section, here you will able to see all the API request, whatever is happening whenever we are putting some value in any particular place. For example, here in the condition I am putting E113, one specific condition related to certain disease. Here you will see that some search happened. If you click on some search, here you will able to see what is the request URL, right? How it is making request. For that, if you want to inspect that, you can go to the payload section, and this is the JSON basically it is passing to this particular endpoint, https://accreference.com/API/search, and it is making a post request. And what are the required headers for this API request? Those also you will able to see here, right? So from this particular information, basically you can easily make a request using request module in Python, and you can perform load testing to this particular API endpoint, right? So for this particular request, we need certain amount of data, right? That is what we'll be sending as a payload. And in the payload, if you see, one particular part what we can change is the search component, right? So here whatever we are searching, so for example search is E here, Like that way, what I have done, I have created a simple CSV file, and this CSV file also I'll be attaching in the description box so that you can download and easily perform the experiment simultaneously. So here if you see dossier, DRF, DXHCC, search. So here if you see those four only we are sending as post request payload. Dossier, DRF, DXHCC, search, right? So search value we are keep on varying. Like that way, here I am having a CSV file. So what we can do, we can read this particular CSV file in a pandas data frame, and we can iterate row by row in that pandas data frame. We can use request module to make post request, get the response code we can capture whether it is 200 or not. If it is not 200, that means it is some error. We will capture that in one particular Cloudwatch metrics. And if the response code is 200, how much time it is taking to give that response, that we can capture in another Cloudwatch metrics. That way we can perform load testing easily on this particular endpoint, right? So based on that, here I have written the simple code. So for this particular experiment, obviously I need Boto3 request module and pandas, and I'll be importing all of them. And here is our main code. So first what I am doing, I am creating the Boto3 client for our Cloudwatch. I am reading this particular CSV file. Okay. So first let me upload this particular CSV file in my Google Colab notebook. So here I will upload this particular data. It is going to take few seconds to upload depending on internet speed. And here you can see the data is uploaded. Okay. So that particular CSV file path I am reading here, and that CSV data I am reading in a pandas data frame. And this CSV data is huge. If you see, if I just scroll below, it is having nearly 30,000 rows, right? But I want to do inspection only with 300 requests. Okay, that's why here I am taking first 300 rows out of it. Okay, and then here this is the API URL and headers, whatever we have basically received upon inspecting the network tab. In the post request, here you can get all these details. So those things I have taken here. And now this particular function is basically helping us to send the metrics data in Cloudwatch. So I will come to this particular part later. So first let's see our main function, make API request. So what I am doing here, basically I am iterating in our pandas data frame row by row. I am taking the payload, or basically creating the payload whatever will be sending as part of post request from that particular pandas row, right? Using simple dictionary key value pair I am extracting that. And here first I am defining the start time, and then I am making a request, and then I am capturing the end time. Okay, so that way I'll be getting the idea that in each request how much time it is taking to respond. Okay, and that response time is basically end time minus start time, and that I am multiplying by 1000 to get the millisecond output. And then here I am printing that for this row the response time is this much. Okay, and then what I am basically doing, I am calling the send metrics to Cloudwatch. Here first argument is API response time, second argument is basically how much time it has taken to give the response. Okay, so let's see send metrics to Cloudwatch function. So here if you see, first obviously metrics name we have to provide. As I told you that in a Cloudwatch custom metrics there are four major important components. One is namespace, one is metrics, one is dimension, and another one is basically unit, right? So namespace, here if you see, here I have given a common namespace ERM, or maybe here I can give API response data custom metric. Okay, right? So this is our namespace where all the API response related information will be stored, right? This will be basically acting as a container for all our matrices. Then here if you see the next point, what we are putting is basically metric name. So as I told you that in Cloudwatch custom metric, another important component is metric name, where basically data will be captured. So here send metric to Cloudwatch. Okay, so the metric name is API response time. So that is the metric name here we are capturing. Then the value part. So what value we are sending here in this particular function call? That is response time. How much time it has taken to respond, right? So metric name, value, and namespace is clear. Then next component is dimension. So in this case, dimension is not needed. So if you recall in our previous video, I have already discussed in detail about the importance of dimension, which basically helps in differentiating two different entities for the same metrics. For example, if you consider a EC2 instance, for this AWS service, one of the important parameter or measurement metric is CPU utilization, right? Now, if you consider CPU utilization for different EC2, then to differentiate in between different instances, we can consider the instance ID as dimension, right? So in that case, based on instance ID, we can differentiate between CPU utilization among different EC2 instances. But here I am only having one API for which I am doing API load testing. So I no need to worry about dimension. That's why I am basically simply ignoring the dimension parameter because that is totally optional. Okay. Now the value part, as I told you, that value is basically how much millisecond it has taken to respond, right? So value part we are putting, and then the unit, right? In our previous video when we have explored Cloudwatch Custom Metrics, the unit we have basically taken as count, right? Because basically that custom metrics we were building just to get the idea that how much time a pipeline failed or succeeded. So that was count type data. But in this case, it is basically how much millisecond it is taking to respond. That kind of data we are capturing. So in this case, unit will be millisecond, right? So that is what here we are keeping. And then using Cloudwatch put metric data, we are basically ingesting that particular data point. And here we are writing metric data is successfully ingested. Right, as simple as that. So this is how the response time will be captured in API response time metric. Now, if in the response status code is not 200, that means API error occurred, right? That also I want to capture in a separate metric. That way I can understand in our stress situation when load is high, how many times API is throwing error, right? That also important. So that also I want to capture in a different metric. So that's why here, if the status code is not 200, I am sending that particular data to another metric. And that metric name is API errors. Okay. And here if you see the value earlier in this particular metrics, I was sending the response time, but here I am just sending a simple count. That is, if one time API error occur, I will make one entry as a count. So this time the unit is count. So by default in this function, I have kept the unit as milliseconds. So that's why in this first time when we are calling, we no need to pass separately the unit. By default, it was taking millisecond. But in this case, the unit is count. So we are specifying here unit as count. As simple as a simple Python function concept. So this is how we are basically capturing two important parts. One is API response time, one is API error. And we are basically calling our this particular function with our pandas data frame. So this is the simple Python code using which we can perform API load testing. So without any further delay, we will run the code. But before that, let me open Cloudwatch and let me keep the metrics tab open. So here we are having all matrices. So here if you see, as of now, we are not having any custom namespace with this particular name. API response data custom metric, right? With that name, there is no custom namespace. So let's see how it goes. So I will simply run my code. So here if you see, row 1, response type this much. And then metric data sent successfully. Then for row 2, row 3, like that way. It is basically row by row, it is iterating. It is picking up one particular row like this way. It is sending this as payload. The response time it is capturing and it is sending to Cloudwatch, right? So here now if I refresh, we should be able to see a new namespace with that particular name what we have configured. And here if I scroll below, here you will be able to see API response data custom metric. This one was earlier not available. But now this custom namespace is available due to our this code run, right? So I will go inside this and here you will see metric with no dimension because we have not provided any dimension, right? So that's why it is not showing any dimension. So here as of now, here if you see only one metric is there. If I go back, now it became 2. So why 2 metric? Because it might have happened that one metric is basically capturing the response time and maybe our API has thrown error also for some request. That's why another metric also got created with the name API errors. So if I go inside this particular namespace, here you will be able to see 2 matrices. So API error and API response time. So why these 2 metric name are coming? Because that's what we are defining here, API response time and API error, right? So here maybe I can click on this particular data. And here as of now no unit is displayed because currently it is just 12:02 AM I can say, right? So we are keep on making requests, so we need to wait little bit. Obviously it is not exactly real time, maybe within 2-3 minutes the data will be displayed. Okay, API response time, maybe you can go to the graph matrix and period instead of 5 minutes you can change to 10 seconds. Okay, and 10 seconds average response I want to take, and here you will able to see some data. Maybe let me zoom this. I want to see only last maybe 5 minutes data. and here you will able to see some graph. So at 12 a.m. our code run started. Okay, API response time initially was 295 milliseconds. If you want to see the units, maybe you will able to see that also. Just make this graph bigger, and here in milliseconds you will able to see the API response time. Okay, so here it started with 295 milliseconds and then it got reduced. Now it is 280 milliseconds at 12:01 a.m. There can be several reasons for this decrease in API response. One reason can be in the back end, the infrastructure might have auto-scaled, which is accommodating the traffic and sending the request quickly, or maybe some API requests are going to cache, and maybe from Elastic Cache or Redis some sort of this kind of cache mechanism, it is sending the response quickly, or maybe directly it is not able to support this much high traffic and directly it is throwing an error quickly. Anything is possible, due to which we are able to see some sort of decrease in the API response. Okay, right. So anyway, I hope the main essence you are getting this. Using this kind of Cloudwatch custom metrics, you will able to understand the API response with huge traffic, basically kind of load testing we can perform, and graph also it is dynamically generating. So maybe if I refresh, I'll able to see some more data. So here if you see one more data point came at 12:02 a.m. So initially it is 295 milliseconds, then it got reduced to 280 milliseconds, and now it is basically 260 milliseconds. Okay, right? So this is how our API response time is varying. Now obviously another important aspect of load testing is how many times error occurred. That means how many times we have not received status code 200. And to check that, we have already created another metric, that is API errors. Okay, so we'll inspect that also. But before that, let us try to calculate using these particular logs that how many times actually error might have occurred. So to understand that, here I have added a print statement that whenever status code is not 200, it will print that row and then API error this particular keyword and then the status code. Okay, so I will just search this one. So here if you see 170 times this API error phrase is available in this notebook. Out of that, here we have already used API error in the code block once, right? So remove this one. So ideally kind of 169 times error might have occurred. That's why it is displayed in the logs, right? API error 403 like that way. So let's see whether our Cloudwatch has captured the metrics around that 169 to 168, that kind of value or not. So to do that, I will go to browse section, and here I will maybe disable API response time and I will check API error part. Okay. So here API error no unit is there. So because we are sending this as count, so I will maybe instead of line graph, I will take this as a number, and maybe in last 15 minutes how many count is there, that I want to see. Instead of average, I want the sum. So here let's see, or maybe instead of 15, maybe 5 minutes I can keep, and here you can see totally 168 times API error has occurred, right? And from this kind of UI from manual calculation also, we got close to 168, 169 count. So that means how many times API error is occurring, that many times this Python code is making an entry in this Cloudwatch custom metrics, and that's why this particular number we are getting. I hope you are getting this particular point. So this is how using simple Cloudwatch custom metrics and Python code we can perform the API load testing. There are two important components. One is API response time. Another one is how many times it is throwing error, right? These are the two important part of any load testing. If the error count is very high, out of, if you see here, out of 300, 168 times we are getting error, that means the infra is not good. We have to do something with this. Otherwise, customers will not be satisfied with this, right? So based on this, maybe the developer team get certain feedback and they can improve the existing infra. So this is another real world use case of Cloudwatch custom metrics. That's what I wanted to discuss and share with you all. This is all for this video. The complete code base I'll be providing in the description box or in the comment section. Try to play with it, then you will be getting a better feeling out of it. If you find this video helpful, then please like, share and comment. Subscribe our channel if you have not subscribed till now. And don't forget to press the bell icon to get the notification of our latest videos. Thank you for watching.